Hello viewer, this is Elim TV. Welcome to Form 3 Chemistry, lesson number 2, gas laws, and today you're going to look at Charles' law. I'm going to be your teacher, Benjamin Makanda. So before we start our lesson, let's look at the specific objectives that we aim at achieving. By the end of this lesson, the learner should be able to state Charles' law, then carry out calculations involving Charles' law, so that once we finish this lesson, we should be able to do this too. Then our lesson is going to have this order: lesson preview, review of lesson 1. We are going to briefly look at lesson 1, then demonstration of Charles' law. We'll look at some of the demonstrations that help to explain Charles' law. Then after that, we are going to have calculations involving Charles' law. Then after that, we will have assessment. So that's going to be the order of our lesson. Now, let's start at looking at what Charles' law is. But before we go to this, how did we relate the first law that we discussed, Boyle's law? We said Boyle's law relates pressure and volume when one of the parameters are kept constant. And this parameter is temperature. Boyle's law says, provided temperature is kept constant, the volume of a fixed mass of a gas is inversely proportional to its pressure. So you see in this case, temperature is kept constant. So these three quantities are what varies in the two gas laws that we're going to discuss. So still on Boyle's law, we can also say Boyle's law is given by, if you have to change conditions of pressure and volume from condition 1 to condition 2, then pressure 1, volume 1 at condition 1 equals to pressure 2, volume 2 at condition number 2. And that formula over there is what summarizes Boyle's law. Now, today we want to look at Charles' law, and Charles' law also relates volume and temperature. But now in this case, pressure is going to be kept constant. So the difference is that whereas in Boyle's law, temperature is kept constant, in Charles' law, it is pressure that is kept constant. So what does Charles' law talk about? What's Charles' law all about? Now, let's look at this. Charles' law, and we have this, look at this photo here. So the relationship between temperature and volume. So we have two photos here. One, we can relate it to temperature, another one is volume. So Charles' law will always talk about temperature and volume when the other parameter, physical quantity, is kept constant. And we have just identified that that physical quantity is what? Is pressure. Now, moving on, Charles' law is also known as the law of volumes. This is the law of volumes. What about Boyle's law? Because if you are saying Charles' law is the law of volumes, what about Boyle's law? So can you research on that and be able to give me the feedback? Now, this is the law of volumes, and then, given that the law of volume is an experimental gas law that describes how gases tend to expand when heated. You know, from states of matter, when you heat matter, matter expands. So when gases are heated, they also expand. And when they expand, what happens? Their volumes increases. And that's why we call this law the law of volumes. Because heating means you are increasing temperature. And when temperature increases, it increases the effective kinetic energy of the particles, which increase the volumes of the particles of the gases. Therefore, the volumes increase. And that's why we call this law the law of volumes. Now, a demonstration to show this, we have a setup here. And in this setup, we have a balloon that is immersed in ice water. The other one is immersed in boiling water. In the first balloon, the balloon is small in size, showing that the volume or the particles of gases there have not spread out. So therefore, they occupy a smaller volume. Now, when you take the same balloon with the same number of the particles and you put in a boiling water, the particles gain kinetic energy. They begin vibrating, expand, and increase the size of the balloon. So from this one, you're able to see something here, is that when temperature is low, because ice water is very cold, then the size of the balloon is small, and the size is equivalent to the volume of the balloon. When you take the same balloon and immerse in boiling water, then high temperatures are going to increase the kinetic energy of the particles, which subsequently will increase what? The volume of the gases, making the volume of the balloon to be bigger. So we have a correlation between the particles, the temperature, and the size of the balloon in terms of its volume. When the temperatures are very, very low, particles do not expand, and therefore their sizes are also small. And when the temperatures are increased, the particles also expand and increase their volumes. So we can now say here that Charles' law relates the variation in temperature with volume when pressure is kept constant. Therefore, to that demonstration, what else can we say about Charles' law? So Charles' law, when the pressure on a sample of a dry gas is held constant, the Kelvin temperature and the volume will be related. So when the pressure of a sample of a gas, the gas must be dry, so that when the sample of the gas, we take the volume of the sample of the gas and we relate with its temperature, then they are related in a way. And we want to describe this one using this one here, this setup here. We have 1 atmosphere in both setup. So they are set at 1 atmosphere, and the volume of the first setup is 0.5 liters. Now we heat these gases, and then you realize that their volumes have changed to now 1 liter. Temperature is now 400 kelvins at 1 atmosphere. The pressure is kept constant. What do you notice here? Increase in temperature by heating also increases the volume from 0.5 liters to 1.0 liters. Therefore, temperature will actually have an effect on the volume of any given gas. So these two demonstrations lead us to what Charles' law came up with. Therefore, what's Charles' law? Charles' law states that the volume of a gas, a fixed mass of gas, is directly proportional to its absolute temperature, which is measured in Kelvin K, provided pressure remains constant. So pressure is supposed to remain constant. Now, if pressure remains constant, then the volume is directly proportional to its absolute temperature, meaning that when you increase the volume or temperature of a given gas, its volume will also increase in the same dimension. If you decrease the temperature, the volume is also going to decrease in the same dimension. Now, we can therefore say that volume of a given mass of a gas is inversely proportional to temperature from this expression that we have here at constant pressure. Pressure is constant. So mathematically, volume is inversely proportional to temperature T. V stands for volume, T stands for temperature. So this is what Charles' law states. And these conditions are assumed when pressure is constant and in an enclosed system. Remember, this experiment must be done in an enclosed system because the particles of the gases, if left in the open, they escape and they may not give us these results. So that's how we want to relate Charles' law mathematically. Now, if we relate this, relating two conditions, sets of conditions of temperature and volume for a fixed mass of a gas at constant pressure, we get this. So this is what we are going to get. We have two sets of conditions, condition 1 and condition 2. At condition 1, we have volume 1 and temperature 1. Condition 2, we have volume 2 and temperature 2. Therefore, if you take V1 divided by T1, you will get V2 divided by T2, where V1 and T2 are volumes of the gases and T1 and T2 are temperatures of the gases respectively. These conditions must be carried out in an enclosed system. So that is the mathematical expression of Charles' law. Graphically, how can we express Charles' law graphically? Now, graph between volume V and temperature T at constant pressure is called isobar. So when you draw a graph of volume V and temperature T, when pressure is kept constant, then the graph that you derive is what we call an isobar. We can also call it isoplastics, and is always a straight line. This graph is a straight line. Now, a plot of volume versus temperature in kelvins at a constant pressure is a straight line cutting the temperature axis. So we have this. This is our graph that we have here. Now you realize in the second graph, the graph has been extended to cut the x-axis at a point negative 273.15 degrees Celsius, which is equivalent to 0. That point is called absolute zero. Absolute zero is the temperature at a particular point that this graph is cutting. It's what we call Charles' law. We said volume of a fixed mass of a gas equal to its absolute temperature at a constant pressure. Absolute means that we are taking volume at 0 degrees Celsius, equivalent to negative 73.1. So that is the graphical representation of Charles' law. Now, the next thing we want to look is the application of Charles' law. So we want to look at the calculations. So we have this one here. Gas of the volume 225 centimeter cubed is collected at degrees Celsius. What will this occupy at 10 degrees Celsius? Assume a constant pressure. We have to emphasize here, pressure must be constant. So we proceed. So we have step to solve this problem here. The step, identify the starting and the final conditions. You have to identify the starting and the conditions. Condition 2, that's the thing we are going to. Now, having condition volume 1 is going to 225 centimeters. T1, you are given 60 degrees Celsius. All temperatures must be converted to Kelvin. 660 with 273, we get our temperature 1, which is 333 Kelvin. Remember, plate volume, we must convert temperatures or scale to Kelvin scale before our problem. So, and then the temperature 2, even as 15 degrees. Again, we convert this one to Kelvin. We're going to have 10 plus 223, which will give us 288. We have identified the starting and the final condition. Then we proceed. The next thing, apply the equation to solve for V. Apply the equation to solve V. Our volume 2 that we are given that we have to solve. So we apply this. And which equation is that we apply? You have it in here. V1 is to V2, solve for the condition. Then the second law is you rearrange the equation to make V2, that's the volume 2, rearrange the equation subject of the formula. 1 times T2 all divided T1. We have just formula. Then last we do, we substitute. So we substitute the value from the equation. This is what we have. 2 is equal to 225 centimeters cubed times 288 all divided by all 3 kelvins. Now in kelvins and kelvins, I mean that the volume you are going to in meters cubed. What is the answer? Get to this. So work out. Compare your answer to what I'm getting here. Do you get this 194.6? If you then that's the right answer, right? 194.6 as cubed. But what is to those steps that were just highlighted in order to add the subtraction? That's how we are able to solve any problem that relates to Charles' law. Homework: why bread rises when baked. The other one that you should explain is why hot balloon rises. So these are the 2 questions that you do as your homework. We move to the next one. Up there,